Hey, welcome. What if I told you the best way to think about your brain isn't as some kind of supercomputer, but as a wobbly bowl of jello? I know it sounds a little weird, but stick with me. We're going to dive into a radical new way of looking at the mind, one that treats our thoughts, our feelings, and even our dreams as actual physical forces.
We've all heard it a million times, right? The brain is the hardware, the mind is the software. It's a really powerful metaphor. You've got circuits, data, processing. But what if it's completely wrong? What if that simple analogy has actually been holding us back from understanding what's really going on up there? What if your brain isn't processing zeros and ones at all, but is responding to the world in a way that's, well, a lot more physical?
Okay, so let's put these two ideas side by side. On one hand, you have the classic computer metaphor. It's all about static, rigid circuits. But on the other, there's this new physical model called the Brain Kinematics Model. And it sees the brain as dynamic, elastic, something that's always trying to find a state of physical balance. It's not about computation, you see. It's about physics.
To really get our heads around this, we have to start thinking about the brain in a totally different way. So forget about electricity for a second, and let's just think about the actual stuff it's made of, the tissue itself. How does that physically behave?
All right, the magic word here is viscoelastic. It sounds super complicated, I know, but you already know what it is. Think about memory foam, or yeah, that bowl of jello. It's any material that squishes under pressure, but then kind of slowly bounces back to its original shape. Well, this new model proposes that our brain tissue behaves in exactly the same way. So here's how it actually works. Every single thing you see or hear, or even just think, creates stress. That stress literally, physically deforms the connections between your neurons. And that deformation, or strain as it's called, spreads through your brain tissue like a ripple in a pond. This process organizes all the neural firings into these synchronized strain packages. A thought isn't just data anymore, it's a physical wave.
Okay, that's a pretty big idea. If a thought is just a physical wave of strain, how in the world does that create the incredibly complex, rich flow of consciousness that we all experience every single day? How do you get from a simple physical property to things like memory and reasoning and just being aware?
Well, at the very heart of this entire model is this one, surprisingly elegant equation. It basically says that your mental activity, yep, everything you think and feel, is the product of your short-term memory flow interacting with your long-term memory structure. You could almost call it a formula for consciousness itself.
Let's unpack that. In this new way of thinking, your long-term memory is not a hard drive with a bunch of files on it. No. Instead, you've got to picture it as a physical landscape, like a vast mountain range, where all your past experiences have been stored as patterns of potential strain. It's the very physical structure of your brain tissue.
And a thought? Well, a thought is what the model calls a stream. It's like a river of kinetic energy flowing through all the complex fractal-like nooks and crannies of that long-term memory landscape. So thinking isn't an abstract process. It's literally the physical movement of energy across the terrain of your past.
Now this is where it gets really cool. This physical model doesn't just explain thought. It gives us this beautiful and almost shockingly simple explanation for our emotions. It turns out that the direction that strain stream is flowing has a huge impact on your mental state.
You've basically got two main directions. When that strain energy flows horizontally, spreading out across different regions of the brain, you get that kind of associative thinking, daydreaming and even dreaming itself. But when the flow is longitudinal, pushing forward along a specific path, that's when you get focused reasoning, problem-solving, and goal-directed thought.
So where do feelings fit into all this? This is what I find so elegant. Emotion isn't some separate system tacked on. No, according to this model, it's something that just emerges naturally. It's the spin, or the friction, that happens when two or more of these strain streams bump into each other and interact. Happiness, sadness, anger, they're all just different kinds of physical interactions between your flowing thoughts.
All right, let's make this theory even more real by applying it to something every single one of us does, dreaming. It turns out your dreams might just be a direct diagnostic readout of your brain's physical state.
Every mental activity you have, from doing a math problem to having a tough conversation, follows this physical cycle. It's called the strain arc. You get an input, there's a buildup of strain to a peak, and then, hopefully, a relaxation and discharge. But what happens if that cycle gets interrupted and the strain doesn't get discharged? Well, your brain tries to resolve it at night while you're asleep, and that's what a dream is.
Which, of course, leads to the big question, doesn't it? If dreams are just the brain trying to physically balance itself out and get rid of leftover strain from the day, what do all those weird symbols actually mean?
This is where the model offers some pretty incredible direct translations. It suggests that dream imagery isn't just abstract symbolism, it's more like a physical status report. So dreaming of dying flowers, that could be a literal visual of a long-term memory motif weakening. A dirty, clogged toilet you can't use, that might represent a blockage that's preventing that strain from being discharged properly. And a haircut, your brain might be physically pruning overloaded connections that have to do with your sense of self. It's wild.
So we've gone from jello to thought to emotion and all the way to decoding our dreams. But the theory gets even bigger. It proposes that this little balancing act happening inside our heads is actually part of a universal pattern that you can find all throughout nature.
You see, this whole brain kinematics model fits inside an even grander idea called continuity theory. The concept is simple, but it's really profound. Any stable system, whether it's an atom or an entire galaxy, is just a collection of smaller parts constantly trying to balance potential and kinetic energy. And our brain is no exception.
And what's the perfect state of balance that all these systems are striving for? Well, it's a number you might just recognize: the golden ratio. In this model, that is the ideal mathematical state between potential energy, your long-term memory structure, and kinetic energy, your active stream of thought.
And that just brings the whole scale of this idea into focus, doesn't it? This isn't just a brain theory anymore. The same fundamental physical principle that shapes spiral galaxies, that creates the patterns in fluid dynamics, and that guides biological growth, is the very same principle, according to this model, that's governing the flow of your consciousness. And that just leaves us with a truly staggering final thought. If your brain isn't a computer but a physical system of strain and flow, and if that system is governed by the exact same universal patterns that shape the entire cosmos, then what does that really say about our place in the universe? And what does it truly mean to be human?